Of this huge number. Right, there's the product, and you now need to find out what the answer to that product is. And it's not only that you find these questions arbitrarily in an Olympiad paper, but it really is an exponential work from grade 11. So we really are revising grade 11 exponents. We need the answer to that product, or we need the product to that question, and it's looking oddly very difficult because we've got this 4 to the 4 and we've got this 5 to the 11. So do we actually go in and multiply 3 times 3 times 4 times 4 times 4 times 5 times 5? That will take us forever, so there must be a shortcut. Right, the first thing you start off with is that's prime, that's prime, that's prime. So the only non-prime factor here is this 4, which we can actually write as 2 to the power of 2, and then we're raising it to the power of 4. After that, we have that this 2 squared, in fact all this equals to 2 squared, times 3 cubed. By altering that format, we now have that that's 2 to the 8 times 5 to the 11. Okay? And the question that we're trying to do is to find what is this equal to, because we need the sum of the digits of the product. So we really want the product first, because once we have the product, we can find what its sum will be. Right, so far we've got 2 squared times 2 to the 8 times 3 cubed times 5 to the 11, which simply gives us 2 to the 10 times 3 cubed times 5 to the 11. Can I shorten this? Well, this 2 to the 10, I could multiply with this 5 to the 11 and make it 2 to the 10 times a 5 to the 10 times a 3 cubed times a 5. So I've split 5 to the 11 into 5 to the 10 times the 5. And now this connects beautifully together, because our exponential law says that if the bases are different but the power is the same, then we've got this happening. A to the 10 times b to the 10 is equal to the product of AB all to the 10. So that's lovely, because that now gives us 10 to the 10 times this 3 to the cubed. 3 cubed is just 27, and 27 times 5 is just 135. So I'm just going to clean this up and make that 135. And now look how beautiful this is, because we've got this 10 to the 10, which is just 1 with 10 zeros. So it actually gives us 135 times 10 to the 10, which I'm not really interested, because that's all zeros, and the sum of zeros is just zeros. So the sum of the digits is in fact 9. So something that looked horribly long and confusing actually can be reduced through exponential work to something that's actually quite simple. So hopefully you enjoyed that. Right, the next one.